Okay. Hello, everybody. Hope you had a nice weekend. Let's get started. Today we will talk about sampling, but I will also come back to some of the stuff that we have left over from last lecture. You know, when we talk about experiments, when we didn't come to talk about quasi-experiments, so we'll talk about that a little bit before we get into sampling. But first of all, remember, it is seminar week, tutorial week. You know the drill. You get the assignment from Blackboard. You complete it. You print it out. You take it with you to the seminar. They take place this week. Okay. So let me come back to some of the things that we didn't talk about last time. So I will just, I want to wrap this up on experiments. And remember, I had talked about 3 different types of experiments, very broadly speaking, right? So there were lab experiments, field experiments, and then quasi-experiments. So lab experiments are these kind of experiments, you know, where you bring people in a very controlled setting, in a laboratory setting. You know, let's say I run a study about wine tasting. I don't know, I invite 50 of you guys to have some wine, and then we sit there. You know, you sit in a little cubicle and you drink that, or you ask, you answer certain questions that have been displayed to you on the screen. But it's a very controlled setting, right? So I, as a researcher, I control the whole surroundings of this, or a lot of it. Well, lab experiments, you know, they are great to really get to the causality that we're interested in. We call that they are good with internal validity. That means when something that I find in this lab experiment, I can be pretty certain that it's the treatment that I sort of administered, because everything else I control. Right? So the only difference is there's one little treatment, whatever it is. Right? Maybe I give you slightly different instructions. Maybe I show you something on the screen. Maybe I tell some people one story and others another one, and so on. Or maybe I use the question wording differently, and so on. Right? But when this happens in the physical setting of a lab, you know, in this cubicle, in a very controlled setting, with no other distracting factors, not in the lecture theater here. So what we did with our little survey experiment, that was not a lab experiment. Yeah, that was actually more like a field experiment, because there are a lot of other things that I couldn't control. Right? Maybe you kind of looked at what the people next to you answered, right? Or maybe you talked with somebody about something, yeah, or a lot of things that I didn't control. Actually, I even didn't control who was coming into the lecture this particular day, right? In lab experiments, it's a different story. They're kind of, you know, it's the researcher who controls all these different things. So they are very good to get to the point of what you want to do, but then people criticize that for, well, maybe we only learned something about this particular setting, right? So that's why we say that lab experiments, they are high on internal validity, but low on external validity. With external validity, in this context, we mean the ability to generalize to the wider population, right? To draw conclusions that go beyond this particular setting. So you see now I'm using validity in a slightly different way than we used to use it when we talked about measurements, right? So you need to distinguish that. There's sort of one way of talking about validity in the context of measurements. That kind of means how good are you measuring something, right? Or are you kind of actually really measuring what you want to do? And then in terms of studies, we talk about internal and external validity, while internal validity means being good in coming to the causal sequence that you want to get, right? And external validity being the ability to generalize beyond this particular setting of the study. Right? Okay, so then field experiments. Field experiments are sort of like a move to more realistic scenarios, right? So moving away from the lab, where everything is very controlled, but also very artificial, right? So a field experiment, when you remember, I showed you this stuff about broken windows, where those folks in Groningen, you know, how cool is that? Put some graffiti on the wall in the weekends, you know, I got paid for it. It was absolutely fine, you know, it was part of the study, and then people walked by, and then they looked at how much do they litter when they see the graffiti compared to people who walk by at exactly the same place when there was no graffiti. Yeah? So that's a field experiment. It's a field experiment. But you already see how now when we, talk about these things that we control, there are a lot of things that you cannot control in a field experiment, right? Who's walking by, right? Or maybe the weather was different, right? I don't know, this one weekend compared to the other. Or maybe, there was an event in town, right? And there was certain, different kinds of people that were there. So field experiments, they move more, but at the same time, the setting was much more real. It was a real-world scenario in a way. Like, do people throw something onto the floor? And if you want to know if people deviate or if they kind of, violate certain norms, throwing something on the floor is pretty close, right? That's sort of a real-world scenario. So field experiments are better in that, and people are moving more into field experiments, and they are trying to control field experiments as much as possible. Okay, so then we have the last one, and that's sort of the stuff that I want to talk now before I get into sampling. It's what we call quasi-experiment. Quasi-experiment. If you remember wonder what this picture is, I say a quasar. It's a little pun at the side. But anyway, a quasi-experiment is not a real experiment. It's not a real experiment, but it looks as if it is an experiment. Yeah? So a quasi-experiment is similar to a normal experiment, but it lacks the element of random assignment to treatment or control. Yeah? So there's not sort of me as a researcher assigning some people to the one or to the other group. But instead, what happens? For example, there are some exogenous shocks that could be it could be a disaster hitting, right? It could be a storm hitting, or it could be a way how something's being implemented. I talk about that in a second. That can be exploited. So there's something else that sort of you can use to separate your subjects into a treatment and into a control group. But it's not really you who chooses that, right? Somebody else. And in the ideal world, whoever does this in a sort of random way. Right? And that's sort of now where these natural experiments come into play. Because you could argue, okay, maybe it's sort of like a random assignment which city gets hit by a tornado, right? Or which city gets hit by a hurricane. But you already see it. Maybe this is not completely random, right? Maybe certain cities are just more likely to get exposed to a tornado or to a hurricane, right? And actually in the aftermath of the Hurricane Katrina, several sociologists did a lot of interesting work on that. Because it was sort of this setting like an experiment. One colleague of mine, he did a study where he looked at attitudes towards migrants before and after terrorist attacks. Right? So it just happened to be like that there was sort of a wider European survey. I think it was the European Social Survey. It happens in different countries, it happens in Ireland as well. But people don't collect the data at exactly the same point in time. So as it happened, there were just a few countries where the data was collected before some terrorist attacks. In his case, it's a paper published in the American Journal of Sociology. It was the terror attack in Bali a few years back. So it was, a very short period where all those events took place, but in between there were these terror attacks, right? And that allowed this colleague of mine to kind of separate the countries before the terror attack from the countries after the terror attack. Right? And that was sort of like a sort of assignment to control and treatment, where he could say then, okay, there's a lot of other things that he controls for, but the decisive element, the difference here is that something happened in between that allows us to assign some people to the random and some people to the treatment group. Another example that I like to talk about, because it's I think a fascinating study. So this one colleague of mine he used to be in Mannheim, now he's somewhere else in Germany. He did this study in Cologne where he looked at recycling schemes. Right? So he was interested in how do people recycle, separating rubbish and getting it recycled. And what happened in Cologne was that the city council introduced a new recycling scheme. They changed from, don't ask me which direction they changed, but they changed from, having bins at the block, at the city block, basically, where you would have to go and throw in your glass bottles or your plastic and stuff like that, right? You would have to physically walk there. They changed that to having individual bins for each household, where you then, I don't know, you wouldn't have to walk around the block to throw in your glass bottles, right? And the key now was that the city of Cologne, they introduced that in phases in different parts of the city. So in some parts of the city, they switched earlier than in other parts of the city. So then what this colleague of mine could do, he could look at how much do people recycle before and after this switch. So here the argument could be that kind of there's nothing too different in between. Let's say we look at how much people recycle the day before the switch happens and the day after the switch happens. So people, I don't know, they're 2 days older, there's not too much difference in here, but something happened in between, which is sort of like a treatment that is being administered. The situation is different now, and then we can kind of look at what is the causal effect of this change in here. Yeah. So that's sort of when something natural happens. Economists love that kind of stuff, you know. They go berserk, but I think it's fascinating stuff where you kind of exploit something that happens, which you can use as a natural experiment. There's another kind of doing that, and I'm bringing this up because I'm working on a paper on this. Some reason it's one of those funky papers, you know. When you get into this, you need to have these kind of stuff, and it's a paper that I only work on every 4 years. It's a paper about the Olympics. Yeah? So you can imagine what happens during the 2 weeks of Olympics. It's happening this year. During the 2 weeks of Olympics, I get sucked into this. I watch all sorts of crazy sports that you don't even know that exist. Yeah? And there I am, and then I get excited about it. And then during this 2-week period, for a few days, I always sit down working on this project. And then when the Olympics are over, you know, I leave it for the next 4 years. So maybe this year I'm going to finish that. What it is a study. Let me mention to you that some other folks found out that people who win Academy Awards live longer than people who don't win Academy Awards. Yeah. And it's one of those puzzles that I had at the beginning. Well, there was a big debate about that. Why is that? You know, does winning an Academy Award, how can that increase life expectancy and so on? Well, and actually, in this particular case, people found that I don't know, if you apply the proper procedure and you remember, there's something called motility bias. Simply that when you live longer, you also have higher chances to win an Academy Award. Right? That's kind of actually that's the key here. So people who don't win the Academy Award, they just and die, you know, they can't win it later on, so the counterfactual is a problem. And people didn't really take that into account. But then there were some other folks that did something interesting that fascinated me. They looked at Olympic athletes, and they found out that Olympic athletes live longer than normal people, non-athletes. I was wondering, how can that be, right? Is there something about, I don't know, winning a gold medal at the Olympics, you know, that kind of makes you happy? I don't know, or that has changed your life. You could think about it in all different ways. You win the gold medal, and then it practically changes your life circumstances, yeah? You get a great sponsorship deal with Nike or with Puma or whoever, right? It can change your life circumstances. So how could we look at that? How could we study if it really is something about winning during the Olympics, right? That kind of changes people's life expectancy. Okay, well now we can apply something that is called regression discontinuity design. Essentially what this does, it looks at a cutoff point or a threshold, and then it looks at individuals slightly above and slightly below that threshold. The idea is that then those people, they should be very, very similar, right? Here the idea is, that's sort of part of this paper that I'm looking at. I'm looking at people who win gold, silver, and bronze medal, but I'm also looking at the ones that are 4th and 5th. Because you could argue that those guys who are 4th and 5th, well, this is professional athletes. We're talking about, I don't know, 100 meters during the Olympics. Those guys really need to know their stuff. I don't know, you just cannot just show up there as an amateur. You go through the whole training exercise as well. You go through the whole practices. You are fit. I don't know. There's no, maybe the winner are slightly fitter, but those guys are all pretty much at the higher end in terms of fitness, right? So this is sort of maybe, and then comparing, let's say, the life expectancy of the first, second, and third, those guys who win the medal, right? So they get all the glory, while the fourth one sort of, is the loser, pretty close, but doesn't get the glory. And then comparing these two groups with each other. That would be a regression discontinuity design. Well, I cannot give you the results, as I said, I need to wait for the next Olympics to do that. But just an example how you can introduce a cutoff point to then say, to argue that the ones that are above and below the cutoff point, they are pretty much the same, so I can interpret that as if those guys in the medal group, as if I assigned them into the treatment group, and the other ones below, so slightly below, I assign them into the control group. So these kind of things are becoming more and more popular, and I think it's fascinating stuff. Okay, so what are strengths and weaknesses of these quasi-experimental designs? Let's talk about strengths first. Well, when you get into and for the assignment, you will have to think about these kind of things. Sometimes experimental designs are just not ethical, or they're just not practical. So remember, I don't know, a while back in this course, we had this puzzle that the acoustics suck. By now we figured it out, hopefully. And one suggestion I found interesting, was one of you guys suggested it has to do with my beard, and I'm mumbling into my beard. How could we test that? Well, the suggestion was to cut off my beard halfway through the lecture. I think it's a great design, right? But the problem is I'm not really happy with that. So this wouldn't really be practical unless you force me, right? And then I might shout, or I don't know, I might kick you, and then the whole thing wouldn't really be very much controlled anymore, right? So you see, it could be impractical. Or there could be things that are unethical, right? So let's say you want to know what does drug use do to people. Now I'm talking about illegal substances, I don't know, some hard drugs. Are you going to force people to inject some drugs? You cannot do that, right? That's sort of, I don't know, that's completely unethical, completely wrong, right? So it's already problematic, when you have some people, I don't know, they could benefit from a certain medication and you give them the placebo, you're not going to help them in a way, but that's a different story. But you can see how administering certain treatments can be very impractical and can be also unethical. Okay, so that's sort of where these quasi-experiments come into play, right? Because these things happen anyway. I don't know. You wouldn't, I don't know, go and destroy a city, right? Like a tornado does. But when it happens, you can as well go there and ask them something about it, right? Or kind of use that as a natural experiment. So a strength of the quasi-experiments is that we can use it sometimes when you cannot use other sorts of experiments, but it's also in the real world, right? So they're sort of less and artificial settings, especially compared to the laboratory experiments. We can generalize it, and at the end, there's also, as a researcher, I cannot choose a manipulation, right? I cannot unconsciously kind of bias who is going to end up in the treatment or is in the random group, because it just happens, it's out of my control, right? It's an exogenous shock. What are weaknesses of quasi-experiments? Well, there might be lots of other things that matter, right? Coming back to this study about attitudes towards migrants, it's not just this particular terror attack that kind of matters there, right? There could be lots of other reasons why there are differences from one country to another, and so on. It's not really a random assignment. No, individuals are not assigned to the one group completely by chance. Sometimes this looks like it, but maybe, now I'm coming back to this point that I had at the beginning. Maybe the people who live in a city that is struck by a tornado or a hurricane, maybe they're just a different kind of people from the population at large. And when you look at the South of America, we just completely see that. There's sort of differences in terms of income, education, racial composition, and so on. Okay, so that's sort of the experimental stuff. Now let me move on to sampling. Sampling, another topic that will stay with us for a little bit. Now we are venturing into first again about how we are kind of what this randomness is, and following up on this random assignment. Now we talk about random selection, but then we also venture into how to analyze stuff and make sense out of the data that we collect. Okay, take out your phones. I have 2 questions for you. Take out your phones. Okay, well, it's definitely not snowball sampling. Snowball sampling, I'll come back to that in a second, means we use it for hard to reach populations. Let's say you want to study a drug user community. How do you study that? Right? How do you get hold of that? The idea there is that you somehow, maybe through experts or so on, you get a first few individuals that fall into the population that you want to study. I don't know, you let them fill out a questionnaire, or you interview them, or whatever you do. You follow them, all sorts of things you can do. But then you ask them to give you names of other people in that community, right? Then you ask them, could you give me the names of some other people who are also drug users? The idea is that through this referral, you kind of get to populations that are hidden, right? And you also get, the trust of the other individuals who participate in your study, because you come with a referral from somebody else. That's what we call snowball sampling. It's problematic in many different ways, especially because we cannot do a lot of analysis that rely on probability theory, because it's not really random, the people that we have. Quota sample. Well, actually, the textbook from where I have this question says this is the right answer. Quota sampling. Quota sampling means, I'll come back to that. Quota sampling means that you fill certain quotas of certain characteristics. Right? So let's say I know in this lecture theater there are 50% males, 50% females. So what I do, I kind of administer certain surveys, and I select half females and half males to fill up that quota. That's the idea. So you look at certain characteristics that you know of the population, and that becomes tricky because you need to know these kinds of things. So it's a pre-specified characteristic that you have. A lot of people said purposive sampling. While thinking about it, you could argue that you have to use a pre-specified characteristic as well. So I would say that's correct too. But quota sampling is actually what we originally meant here. But with purposive sampling, the idea is you select certain individuals that you think that could help you to answer that question, or who are representative, or maybe who might be more likely to respond to you asking them about helping you for the study. Probability, well, it's not really probability sampling. when you use a pre-specified characteristic. The idea with probability sampling is that individuals have an equal probability to be selected, and through that you get a representation of the population. Okay, let's look at the second one. What is the list of elements from which a probability sample is selected? Confidence interval, confidence level, sampling frame, symptomatic sample. The correct answer is sampling frame. Sampling frame is the correct answer. The other ones are all wrong. Confidence interval and confidence level, we'll come back to that next week. It's something that we use to assess how confident are we in the results from our sample. I go and I sample, let's say I select 10 people here from this room, and I give you an example. 10 people, I select them somehow from here. And then I look at that, and then based on the result, I kind of make conclusions about how good you will do in the exam at the end of the term for the whole general population of all the students here. That would be a confidence interval to say how confident am I to draw conclusions from the we call that statistics that I derive from my sample. And confidence level and confidence interval, they are closely related with each other here. Sampling frame, that's the correct answer. Basically means a list of elements from which a probability sample is being selected. It would be like, I'll come back to that, it would be like a roster of students that I get from the registrar at the university. I ask them, I want to do a study on whatever. Please give me a list of everybody who is studying here at this university. That would be my sampling frame. Okay, but I come back to these kind of things. So what I have now for you, I'm going to talk about sampling a little bit, and then I'm going to talk about 4 procedures of non-probability sampling and 4 procedures of probability sampling. So we will make this distinction, and for each one of them, I'll talk a little bit about strengths and weaknesses. I also brought some other stuff, but most likely we're not going to get there about randomness and sampling distribution, but these things will stay with us. Okay, so sampling. Well, sampling, what does it mean? Or let me start this with an example where most of you probably can relate with. Sampling plays a big role when it comes to elections. There's an election coming, or there were some elections, or maybe there's going to be some more elections. Who knows in this country? And when you look at elections, let's look at Ireland, let's look at the last general elections. There were around 3.5 million people who had the right to vote. That's the number of people who could, that's what we call the electorate. Now what they did, at the end of this, I don't know, there was election day, it was a few weeks back, and you watch the news. Have you ever wondered how they know at exactly the time when the election booths close, and I don't know, a few seconds later, they show you the results? How the hell do they do that? Sort of like a magic trick, because it's impossible to look and count all the votes in that short amount of time. So how this works is through sampling. More precisely, it works in this case through exit polls. Exit poll is essentially, there's sort of some guys, they're interviewers, often it's students like you, that stand in front of the places where people go to vote, and then as people come out, they ask them, which party did you vote for? That's what they do. And then they collect the data over the day, and then they prepare it, and then, I don't know, a few seconds after, whenever the time finishes, there's some results. When you look closer at what they do, those polls are based on a very, very small sample. So for the RTE, from the exit poll from the Irish Times, they asked around 5,000 people. 5,000 out of 3 million, right? And for the exit poll from RTE, they asked around 4,000 people. 4,000 out of 3 million people. So it's less than 0.5%. It's just 0.015% of the population were asked to tell them what they were voted. But when we look at the results, so now these are the results from the Irish Times exit poll. First, you see, these are sort of the poll results. And these are sort of the final results after people actually went through all the 3 million, I don't know, it was less than 3 million who voted. and counted them. And when you compare these numbers, they are very close. Actually, they are extremely close. How do they? Well, of course, there's still some variation. You look at that. Sometimes they not only hit it, but when you look at it, it's almost always less than 1% difference, right? So it's incredibly, incredibly accurate. How do they do that? How do they do that? Well, it's through sampling. It's through sampling. So they select a subset of the people, ask them, and then based on that, they kind of then derive conclusions for the general population. Why do we do that? Well, because often we cannot study an entire population, or it's just incredibly expensive, or it's incredibly time-consuming, so on, right? Then sampling is a procedure which is fascinating when you think about it, that you can only look at a very small subset of people, and still you get incredibly, incredibly good accurates about the general population, right? And actually, the funny thing is that it doesn't really matter. It doesn't really matter how large your population is. If I would be in the United States, or I don't know, well, that's a bit more tricky, but let's say it would be, I don't know, in Germany or in France, asking 3,000 or 4,000 people would be fine as well. Although the population is 20 times as much as an island. But you still would get almost as good as results as over here in Ireland. Right? So that's sort of this fascinating thing, that the actual size of the population doesn't really matter for what gives you a good sample. So the idea with sampling is, that from a sample, from a subset of the population, we can infer statements about a general population. How does sampling work? Well, there are a bunch of steps in here. The first one is, I come back to that, define the population. Like, who are the guys that you want to know something about? Right? Then the second one is define the sampling frame. Means getting this list of people who are in your population, right? So that you can actually select some of them from there. If you don't have a list of who lives in Ireland, if you don't have a list of the students who are here, and if I just walk around or sit in the arts cafe and wait who's walking by, this is not a proper sample, right? Because the sampling frame is unknown. I don't know who is walking by. It could be, I don't know, everybody. It could be other people walking in. So that's sort of a sampling frame, but I come back to that again. And then we choose one sampling procedure. And there, the big distinction is between non-probability sampling and probability sampling. Non-probability sampling means that you don't know before you go and select individuals what the probability of a particular individual is to end up in your sample. While probability sampling means you know how likely each individual is to end up in your sample. That doesn't mean that this individual will end up there, but you know the chances for that individual to end up in the sample before you go and select your sample. Okay, so that's the stuff that I want to talk about. Start with the population. It's a term that we use here. In sampling, we talk about population as the group or the collection we are interested in generalizing about. It comprises all people, or it could be organizations as well, or other units and so on, with characteristics that one wishes to study. So the population could be people who can vote in Ireland. It's sort of these 3.3 million people. Or another population could be all students at universities in Ireland. Or another population could be all students at UCD. But you see that then all the things that I kind of find out in my data, I can only generalize to my population. So if my population is all students at universities in Ireland, I cannot generalize from whatever I do in my sampling and then I find something out. I cannot generalize from that to students in the United States or students in the UK, because that's not my population from which I selected my sample from, right? So population is the group about which we want to generalize. And that's often what we want to do, and that's the whole point of sampling as well. We cannot study everybody, but we select a smaller group, and then we infer about the larger group from the sample that we studied. Okay. So in contrast, a sample to that, a sample is a subset of the population. It's just a chunk. It's sort of the people that you interview at the end of the day, or the people who who end up filling out your questionnaire, or the people you bring into the laboratory environment to participate in an experiment. That's then a sample of your population. And the link between population and sample, well, that's where the sampling frame comes into play. So you link these two with the sampling frame. A sampling frame is essentially a list from which a sample is selected. And now you see there can be already some discrepancies, right? Sometimes not everybody in the sampling, in the population, is part of the sampling frame. Imagine that I want to do this study about students at in Ireland or students at UCD. Maybe some people, when I go to the register, I get this list, I have all the names, and I can see it, and then I can write you emails about it, invite you to participate, to have some wine with me, and but maybe some people registered late and are not on that list, or maybe some people dropped out since they registered. So you can see how the list doesn't necessarily completely overlap with the population that you study. And it's very clear when you do these kind of things, when you apply sampling, to be very clear about what is my population, what is my sampling frame, how do I get this list, what is on this list, and then how do I select individuals from this list to end up in my sample. So that's sort of the last step. So we have the population, we define the population, we define a sampling frame, and then we go and choose, we define the sampling procedure that we want to use. Okay. So now, as I said, the big distinction is between non-probability sampling and probability sampling, but hopefully these things will become clear as I walk you through that. What I will do, I will walk you through 4 non-probability sampling procedures and through 4 probability sampling procedures. Okay, let's get started with non-probability sampling procedures. The big point about non-probability sampling is that the probability for each member to get selected is unknown. So I don't know a priori how likely it is that a particular individual ends up in my sample. That's basically the thing that defines a non-probability sampling. There are the 4 most common ones, or used are convenience sampling, snowball sampling, quota sampling, and judgment sampling. So I will talk about each one of them, and I will briefly mention some strengths and weaknesses for them. Okay, let's get started with a convenience sample. A convenience sample is really just using whatever sample is convenient for you. So let's say I'm going to sit in the arts cafe and I'm going to ask people who walk by. Right? I don't know, I'm asking to visit in a study, I'm going to interview them, or I give them a questionnaire and so on. But you see how this is, well, first of all, it's very convenient. I just sit there, drink my coffee, right, and I do study while I have a good time. I run some experiments or something. But it's also pretty arbitrary. It's pretty arbitrary. Maybe some people just don't go to the arts cafe, right? I don't know. Maybe have people brought their lunch, they have lunch elsewhere, or they go home. All sorts of things that can happen that kind of makes the people that walk by exactly at that moment when I'm there, that these people are not necessarily random at all, right? That's sort of the big thing about convenience sampling. On the one side, it's incredibly convenient and incredibly cheap, and it's sort of good if you want to get started, get an inexpensive approximation of something. But for a proper study, a convenience sampling is pretty bad. Right? It's just lazy. It's lazy, and in consequence, you cannot necessarily generalize from whatever you find. So when you find something using convenience sample, great, but how do you know that this sort of is representative of the population, right? You don't really, and that's sort of the big problem with that. So 2 examples of convenience samples also would be, let's say, all students in the L Theater on 4th April 2016 at 11:30. It's pretty convenient for me to study you guys. You just come here, right? And that's actually a convenience sample. Another convenience sample would be if you go out into the streets, just randomly you position yourself on Grafton Street and you ask some people who walk by. It's very convenient, but it's not really a random sample. So that's a convenience sample. Advantages, very easy and cheap, doesn't require a lot of time and effort. Disadvantages, the sampling frame is unknown. You see, there's not a list. I don't have a list of people who are going to walk by in the arts cafe at a certain hour. I don't have that list. Yeah? Maybe, I don't know, probably I could get a list from all the people who should be here at the lecture at this particular moment. I do have that list. But often in convenience samples, the sampling frame is not known. And the consequence of that is that the people that I then study are not necessarily representative for the overall population that I'm interested in. Okay, convenience sample, basically avoid it, maybe use it to do some exploratory research, but it's not really good. Yeah. So when I read master theses and people do that, I think, oh God, what are you doing? Why do you use a convenience sample? It's just bad, and it gets particularly bad when people then use procedures that they can only use for random samples, right? They go and they kind of sit in the arts cafe, and then people walk by, and then they kind of collect some characteristics from them, and then they say, I don't know, this is sort of how the population looks like, yeah? Or this is sort of what we can draw from that. Let's talk about a second form of non-probability sampling. It's snowball sampling. Snowball sampling, as I already mentioned, that's what we use for hard-to-reach populations. It's basically you ask somebody who has certain characteristics or features to help you to find other people with that characteristic and feature. That's what we call snowball sampling. It allows you to get to hard-to-reach populations, drug user communities, or I don't know, people with certain diseases or things like that. It's really difficult to get into these groups, but it can be incredibly important to study that. Disadvantages, that it's usually impossible to determine the sampling error or make inferences about population based on the obtained sample. What that means is that this probability stuff doesn't really apply to that, because the people through snowball sampling are not really random. Right? So I did this study, I don't know if I mentioned it to you guys, but writing this paper, I'm going to talk in my other lecture about this, that the friends of your friends are not random anymore. Right? So your friends of your friends actually are likely to have more friends themselves. It's mind-boggling. Yeah? That's kind of a little strange. And actually, I like to tell this to especially established dudes. I tell them in their face and say, your friends are likely to have better friends than you, and actually your friends are also more likely to be attractive than you, more attractive than you, and fitter and healthier than you. Yeah. Writing up this paper right now, so hopefully you can read it at some point. But it's very straightforward, it's very simple. The reason is that individuals who have lots of friends, they just show up in a lot of friendship relationships, right? I don't know, somebody who is very isolated, has only a limited number of friends, there are only so many limited other people who actually see this person as a friend. The ones who have lots of friends are seen by lots of other people. So when I start somewhere and I randomly ask somebody to name me a friend of theirs, it's more likely that this person has lots of friends. Because it's sort of a selection problem here. Because the individuals that don't have many friends, they don't show up in friendship relationships, so they don't get recommended, right? And then the next step, and that's sort of where my paper is, or you can read up on that if you want to. I have one paper published on that, that these positions in networks, they correlate with a lot of attributes. So we know that central individuals tend to be have certain attributes. They are innovators. They are they are more in the midst, they perform better, and actually there's even a correlation with attractiveness, and that's what I show. It's very small, it's not very high, but there's a small correlation between the number of friends that people have and attractiveness. But bringing these two things together means that random friends of a random person are not randomly attractive. So that's one of those things. And that's snowball sampling. There you see what the problems are, because that means we don't really get a random sample through this procedure by going through these referrals. Right? So that's sort of a major problem with snowball sampling, why the whole probability stuff doesn't really apply. Okay, let me go on and talk about quota sampling. Quota sampling. Quota sampling is non-probability sampling in which units are selected into a sample on the basis of pre-specified characteristics, so that the total sample will have the same distribution of characteristics assumed to exist in the population being studied. Right? So for example, I know the world there are approximately 50% males and females. Actually, funnily, it's slightly different, which is a very interesting puzzle as well. Right? Why are there slightly more, I don't know what it is more females or males, but they're slightly off evolutionary. It's a big puzzle. Why isn't it split 50-50% in the overall world? But let's say I know that this is sort of how a characteristic looks like. Then I go and sit in the arts cafe and I ask, I don't know, 50% 5 females and 5 males to participate in my study. And as soon as I've reached the quota, kind of a fraction of people that I want to get, I stop sampling individuals with that characteristic. But it's pretty arbitrary how I select the individuals to end up in this quota. So the idea is to start with characterizing the population based on certain desired features, and then fill these quotas, and after a quota has been reached, stop getting people with these characteristics in your study. And when we look at voting, actually this is what is often being used. So because when people go and ask people about what they voted for, you want to get, you want to get people from working class background, you want to get richer people, you want to get people that have different features with different social characteristics. So quota sampling is often used. But how do we get to know which kind of quotas that we should fill? And that's sort of the big problem with quota sampling. If you have wrong ideas about how many rich people or how many poor people there are in your country, you cannot really assign a quota for that. So that's actually, where this thing here comes into play. It's kind of funny that I got this yesterday. So there's somebody knocking at my door yesterday from the Central Statistics Office. That's the census in Ireland. Probably you got it as well. Incredibly important, because without that, we are really screwed with these kind of samplings, right? Because that allows us to give us an idea about how the population looks like. So I have some other stuff, but maybe I just leave it like that and talk about that more next time. There's some reading I want you to do. Quadrature pages 119 to 127. See you on Wednesday.